Let's get started. Today we are going to be looking at Solidity. If I'm to share my screen. So yes, we've all been hearing about learning this course, and yes, in the previous times we looked at why should you learn this course, at APIs and how to integrate them into React. We learned about JavaScript, and this time we are going to learn about the core, which is smart contracts. So Solidity is just an object-oriented language. It's a high-level language for implementing smart contracts. And for most of the protocols that we see that are built on top of blockchains like Ethereum, they use Solidity as a programming language. So our aim today is to simply look through and get familiar with Solidity, introduce it, and look at some of the mechanisms of writing it. So if I look closely here, so it is a statically typed car braces programming language designed for developing smart contracts that run on Ethereum and other EVM compatible chains. So okay, so when we are writing this program, we usually use a few environments or some environments. So if you're going to write this language locally, you could use things like Hard Hat. If you're going to write it, if you want an online environment, you could use something like Remix. So we are going to be testing most of our syntax using Remix IDE for today. There is also writing a smart contract using Foundry. It's one of the most recommended developer environments because it gives you the ability to really debug in a flexible way. So Remix IDE is I think it is ethereum.remix.org, remix.ethereum.org. This thing they're watching is as a mobile redirect, so let me refresh. Remix, I think it's supposed to be remix.ethereum.org. You need to be conscious so that you write on the right. Yeah, this is how it looks like, and it's a simpler developer environment where you can quickly bootstrap a smart contract, a place where you can quickly deploy it and see how it reacts both on-chain and in a virtual environment. Yes, so we are going to be using this so much for this session to write some of the starter smart contracts. But as we are looking at it, we are simply exploring all about this thing that we call smart contracts. So as we've said, the programming language is Solidity. Some of the great places to always check out and practice is this platform called the Solidity by Example, where you see different use cases as things become bigger and bigger and bigger. And you can also look into protocols, look into their code to see what you've learned and started. So with that said, I think the other platform is learnweb3.io. I think we are going to have to answer some of the questions here and learn a bit from this place. There are very many other places where you can kickstart your journey into smart contracts. Smart contracts are highly a very critical part of the Web3 because they are the building block, and when a vulnerability is found in a smart contract that you've written, an entire protocol or an entire treasury can be depleted by any malicious actor, because these are automated kind of code that, you know, that does it cannot be reversed easily if finality is reached. So yeah, that also breeds other places where, you know, there are bounties um, for builders that are finding bugs like Immunify. So these are just platforms where if you go into a protocol, find a bug in a smart contract of that protocol, then you can be paid wholesomely if your review is taken into consideration. So yeah, this is a place where you can research and see bug bounty programs, vaults, manage triggers. So we can look at bug bounty programs, and no. Explore Immunify. Oh, they now have a token. I didn't know. I think I see explore bounties. And other platforms like Cantina. These are all platforms that if you've developed your Solidity skills so well, you can always come and you know, so all these bounties, you'll Uniswap. So if you find a bug, Coinbase, Morpho, Pendo, OKX Lab has also a bounty live. Yeah, and Ventures Bug Bounty. So here, so yeah, this is a platform where you can flex your muscle, Pancake Swap Infinity, and see Li-Fi contracts bounty. If you've used Li-Fi, yeah, Kiln V1 bounty. So this is a platform where you can also come to, and it's free to participate, register and participate freely. So also I think also Immunify does that, and many other things, other tools that come around because of, you know, Solidity, because of being very good at Solidity smart contracts. Yeah, there are many I think other tools that have been built. So okay, bounties, all these are bounties on the Immunify platform. So this can be a great reason for you to really learn Solidity in depth, and yeah, give it a good try. So with all that, I think we can simply go to learn something. So yeah, building Solidity. So we are going to build, so first of all, let's take a tour of this platform, Remix IDE. I think it is found on remix.ethereum.org. There is also another online platform, I think it's called Atlas. I don't know, it's Atlas Studio, Atlas Smart Contracts. Yeah, it's atlaszk.com, and this is a platform where you can also deploy your smart contract. So yes, with these two platforms, you can really flex your muscle on building smart contracts. So we are going to stay right here. I'm sorry for that inconvenience. Okay, back to my screen, and yeah. So this is the Remix IDE. It has this panel here. I think it's a sidebar. I can call it a sidebar. So first we have the AI assistant. We have the file explorer, where you explore files. We have the search. We have the Solidity compiler. And we have the deploy and run transactions. And then we have plugin manager. So with the plugin manager, you can add in plugins, maybe plugins that verify your smart contract, a plugin that does something from the Remix IDE. And with this, you can create files and yes, Solidity files. Here we have the create. Here on this panel, we have the create. We are after the leftmost. In this panel, we have the create. We have contracts, scripts. We have some folders here. But here on the create, we have a drop down on the right. You can create a new workspace folder where you are going to put probably your smart contracts for that kind of work. You can upload files, upload folders, and import from IPFS and things like that. So we shall mostly use a new file and new folder. We have this button, play button, which is for compiling. We are also going to be seeing shortcuts that we can use in compiling. Okay. So mainly, I'm going to create a workspace, a new folder, and I call it Solidity Go. Solidity. Solidity 101 or anything you can. And in this folder, just can create now a file, but you can simply create a file. So the new file, I can call it that file. Hello. So with the Solidity, we use an extension of .sol. Yeah, it's the extension that is used to depict Solidity files, and the way we start our files, we start with pragma Solidity. So, and then the Solidity version that you want to have. So maybe I can say 0.8.19. So what pragma does is, as you've seen after covering it, there is warning SPDX license not provided in Sourcefire before publishing. Okay, that we shall see. Pragma is the way you write when you want to specify a Solidity version. So whenever you are starting a program, you really have to specify a version. So if I put just that means that I'm going to write a Solidity program that will only be compiled at this Solidity version without anything. If I put this caret, it means that it will this IDE will make sure that it is compiled for this version and all the versions above it. So when I come here, I think it's right here in this remix. Okay, maybe let me just say contract. So the way you start Solidity, you start with the contract keyword and then the contract name, hello, and just like that we have a Solidity file. So we can come here where there is this. So we had this, the search, and then the Solidity compiler. So you can come here at the Solidity compiler and say compile. So you see that there is this, but it has compiled. So this Solidity compiler, as you see here, there is the compiler name, there is 0.8.31 plus commit. So that means that this program will compile from the Solidity version of 0.8.19, which is 15 from here, and all the Solidity versions above that. So if I compile again, you see it has compiled, and if I put this to a version below and click compile again, it will not compile. So it will give you this from Solidity warning, license identifier not provided, but this is a version that is below. So it actually didn't even compile, it just went to a version that is above this automatically. So to remove this error, you have to start by commenting the license. So in most of the Solidity licenses, we use the MIT license in most of the Solidity smart contracts. So if I'm to look here and probably just get it from here. So there is this Sores SPDX license identifier, MIT. Some is unlicensed, so I'm going to just have it. So you always have to start with the license and you put it as a comment. Sometimes you can use unlicensed. I think it is unlicensed, but most of the time we use MIT. And if I save this or if I compile it, you will see that there is a tick. So if I go to a version below A19, it will not compile actually. So instead of always coming to compile, to click on the compile button, you can also use the auto compile. And when I check the auto compile, it gives me the it always compiles whenever any change is made. Maybe if I write something in the smart contract, it will always recompile and always compile whenever there is a change made. But you can also turn it off by clicking that same button. Okay. So today our aim is not to really go very far, but at least we can lay the foundation and write some code to, otherwise maybe if I go any further, are there any questions? So since there are no questions, we can go a bit further. So this is how we declare our smart contract, and with this code alone we have a fully fledged hello smart contract. So with this we can add functionality to it, and the next thing could be, how do we declare variables? So declaring variables. So the variables are usually broken down into three categories. We have one is the local variables, and second is the state variables, and three is the global variables. And for the local variables, they are always declared inside the function and not stored on chain. And what does this mean? So in case you want to really declare a local variable, you have to have a function. So maybe let me say here we have a function let me say greet, and where that's greetings. We are going to be seeing these other things, but we simply have a function greetings. Probably let me even remove this, and okay, it has to be there for now. An identifier, and here I declare a variable uint 16, number of times, so this variable that is declared in here is a local variable because because of its nature, public, pure, maybe probably returns, but no, let me just leave it at that. So this variable that is declared here is termed as a local variable, and even before going that further, how do we declare these variables? So we have a state. So state variables are declared outside a function, and whenever they change the state of the contract. So whatever is always declared here before a function. Let me first remove this. I think this can be the start. We start with this as 1, and this as 2. So whatever is declared always after, probably after declaring all outside of a function in a smart contract, is a state variable. And how do we declare these variables? So variables are declared using mainly 4 keywords. So we have strings. Let me just leave this public. We have uints. Uints are unsigned integers. So uint 256, uint 64. If they are 2 to power something, a public num. And then we have booleans. So boolean, and whenever you declare a variable, you have to give it like whether it's a public or private, but we are just going to declare them and just see how they are declared is true. So wherever you declare something as a boolean, it will always be returned either to true or false. So it will either return true or false, and I think by default it's true. Is it true or false? Probably can be rectified on that. And then there are other things like enums, addresses, enums, structs. So enums and structs are types that are user defined, but we shall see that most of the time these are the variables that we look at: strings, uint, bool, and then local variables declared in a function. And so if you want to look at, thank you so much. So if I don't, for example, assign it to true, so it will automatically be assigned to false. So if I don't assign a boolean value to true, it's automatically assigned to false. So yep, after declaration, I am usually explicit. So then global variables are those that are already embedded in the EVM. Things like you have address, public. So address is an address. Public may be, let me just say my address. So this will capture a wallet address. There are also other things like block.timestamp, msg.sender, msg.value. These are variables that are incorporated into the language. Okay, so we've said with the state variables, that means that if I get this variable and change it, and change its state to something else, that will be written on the blockchain. But if I get a local variable and probably there is changes that occur in here within this variable, those changes will not be written on the blockchain. That's one big difference between state and local variables. Okay, so we can continue a bit further. Otherwise, if I'm moving so fast, we could reduce the pace. My aim today is to simply get us comfortable. So the resource that argument is address a global variable or a state variable. Let me look. msg.value. We shall be seeing this msg.sender as we progress. So we are not going to use this. Global variable or a state variable. In Solidity. So that we shall look at it. Seems to be not a clear answer. So now we can move into So maybe if you want, for example, to get the time now of maybe doing, you could set it uint maybe time at this recording, or block time at recording, block recording time, and is assigned to block.timestamp. And type error function declaration pure by this expression potential reads from. Okay. Can remove this for now and remove the pure. Yeah, to have this block.timestamp. So this will pick the time at which this block is created, at which or at which maybe the smart contract, this smart contract is deployed, if it is deployed. And this is a state variable, block.timestamp. So you could have let me say my address being assigned to msg.sender. Now these are defined within the language, so address public, my address, okay, just something like that. So that means that this msg.sender is a global variable because it was declared within the language. So these uints have ranges. As we declared uint 256, you can have uint 8, uint 8, uint 16, uint 8, uint 16. There are powers of 2 up to uint 256, and uint 256 can store a value of 2 to power 256 minus 1. To power 256 minus 1. Hope this will make sense. Yeah. So yeah, uint, these are unsigned integers, and we also have int, which we have uint and ints are signed integers. So you can say int I, and we assign it to probably negative 15, and yeah, things like that. So this is how we declare variables. If you've done other languages, this is not far-fetched, but okay, let me leave this here. All right. So we can dig a bit deeper. Yes. Okay, so these specifiers can be also private. So the reason we specify it public is for it to be accessed by other smart contracts, and also outside of the smart contract. So that was a good question. Let me see if I can show you clearly. So if I deploy this, and So if I deploy this, when everything that is public can be accessed publicly, like here. So this can, when you see greetings, it's true, message, address, num, this can be accessed like outside. Maybe can be accessed from the front end. They can be accessed by another smart contract. So if I click my address, there is a 0 address. Yeah, so if I make it private, where is the address? If I make it private and I compile again, after compiling, it automatically compiled, but I can be sure. So after compiling, then I deploy. You will see that the address is not part of this of the buttons or of the variables or even functions that can be accessed publicly. So that specifier really helps. Even function greeting, if I make it private, it will not be accessed by outside smart contracts. Yeah, thank you. So where are we? So we can add on something. Probably go to specifiers, or we can first move to loops. I don't know. So yeah, this session really, my aim is for us to just have a hang of the entire thing. So I wouldn't want, I'm tempted, but I wouldn't want to really start diving deep in the first session of smart contracts. Yeah, so we've looked at the resources, opportunities, and also maybe on the opportunities we have as that is loading, we can look at other things like specifiers. I feel I'm starting to dive in, which is absolutely necessary, but you know, since this is our first session on smart contracts, I would love to keep it open. Yeah, you can look through a lot on Learn Solidity by example. We are going to be building a lot from here. We're also going to be getting a lot from learnweb3.io. Yeah, so probably we could go through the questions and what does uint stand for? Unsigned the int age, of course. What is the range of uint 8? 0 to 2 power 8 minus 1. What's the default value of a Boolean variable? I failed it. It's supposed to be false. Thanks to Manuel. What's the default value of an address variable? Sorry, 0, 0. So yeah. What is the significance of the public keyword in a function definition? Function can only be called internally by the other smart contract. That one is wrong. It can be called from within the contract and also externally. That's right. What's the significance of the view keyword in the function definition? Then we can go to that. It means that the function can change. Okay, array strings. Okay, I think that would be deep. So as I was launching. Also here are hackathon platforms where you can apply your knowledge together with smart contracts, building some things. Solidity hackathon, 7 days left. Liquidity index, I hope. Lux index API, we did APIs, so you could try this hackathon out. Raise mirror on the wall, I don't know about that. Designing smart DeFi savings, hack with your designing smart DeFi savings. Okay, seed star. So yeah, at least with the knowledge we have, you can do some things like this. And yeah, with smart contracts, I think most of the hackathons here will be doable. So unless there is something else for today, I really want to leave it there. Tomorrow we are going to dive deep a lot. So come with your seatbelts. Yeah. Any questions? Okay, that's a good question. So smart contracts are actually, a real smart contract is like an agreement, a deterministic agreement that is deployed on the blockchain. So right here, if I change, so let me deploy one. So yeah, as you've been asking, so what's really, can you create one? So one of the things you can do is, for example, if you're building a product, you're building, let's say, a savings app, the back end of the app will be a smart contract, and you can interact with already deployed smart contracts if you are given, if there is permission in those smart contracts. Let me put remix. You can deploy your smart contracts, and you can also audit other smart contracts. Yes. So maybe we can go through all things. So when you are auditing like a protocol, that means a protocol, these are a set of smart contracts that were deployed. And what you want to do is you want to audit those smart contracts. You want to find bugs and vulnerabilities in smart contracts. The reason why we also say that blockchain is transparent is because when a smart contract is deployed and verified, you can read through the code, and that's what also gives hackers the opportunity to see if they can, they can get away of maybe infiltrating this code of draining if the smart contract stores funds. So that's all about smart contracts. It's like a replacement of the back end with something that everyone is open to the public scrutiny. Yeah. So when I try to deploy, I think I'm really getting a slowing thing here, but that's it. So yeah, tomorrow we shall deploy. In the course, we shall also be reviewing some smart contracts. We shall also, like, time will come and build smart contracts and also front ends to interact with them. But as of now, yeah, we've learned, I think, React to interact with APIs that are getting maybe data from indexers, but we can actually write our own smart contracts. We can talk to other deployed smart contracts uh, based on the permissions of those smart contracts, and then we can also audit and see if there are vulnerabilities. Yeah. All right. Is there any other question? Wanted to deploy, but it seems my thing is going to be too slow. So if there are no really a lot of questions, I want to end here for today. Thank you for coming. That's the introduction to it, and all the nuances. I think tomorrow we really shall move fast and cover a lot. Have a great time.